The biggest thing I will say, because I will take points off for this when simplifying, especially solving quadratics, if we have I, or negative, inside the radical, it's got to come out as I. If you leave a negative inside the radical and don't rewrite it as I will take points off of that. Where we're picking up is our discriminant. Now, for the review sheet, I asked for the value of the discriminant, our b squared minus 4ac. We want to know what its value is. 2, we want to know the number and type of solution, so either 2 real solutions, 1 real solution, or 2 complex. And then the third thing the review asked for was the solutions. It actually asked you to solve it. On the test for this part here, it's going to ask for the value of the discriminant. It wants to know what b squared minus 4ac is, its value. The number and type, so either 2 real, 2 complex, or 1 real. That's it. I'm not asking you to solve it on the test for these here. 28 or 29? 28. 4x squared equals 5x minus 10 is what we're going to look at. With these here, we got to make sure that the equation is equal to 0. If it doesn't have an equal sign, it's just we got to get it on the same side. That's the goal. So 4x squared equals 5x minus 10. What I would do is subtract 4x squared from both sides. Because the big thing is that it's getting it equal to 0, not so much that we have a squared being positive or whatnot. Because here, if I want to get it equal to 0, the 2 directions we can go is one is just move that 4x squared over. We subtract it from both sides. It's now equal to 0. The other option is to subtract 5x from both sides and then add 10 to both sides. I would rather move one thing instead of moving 2. Less work. A is negative 4, B is 5, and C is negative 10. So the first thing we need to find is the value of the discriminant, our b squared minus 4ac. Well, b is 5, a is 4, negative 4, and c is negative 10. So we replace b with 5, a with negative 4, c with negative 10. At this point here, I would grab the calculator and say 5 squared minus 4 times negative 4 times negative 10, and hit enter. Tells us negative 135. I assume. So the value of the discriminant is negative 135. Questions on this here? Now the second part of it, it wants to know the type of solutions. So if b squared minus 4ac is greater than 0, it's 2 real. If it's equal to 0, it's 1 real. And if it's less than 0, it's 2 complex. Since its value is negative, it is less than 0. So we would have 2 complex solutions. And that's all the test is going to look for. I'm not going to make you solve it. I'm not going to make you find the solutions to it. This is all I want. I want these 2 things. Questions on this here? We ready? Yes, the full video, I did post it, which is going to do all of them, is up there. So if you want to go back and rewatch any of them, or see, especially on some of them, I do it on the solve by any method. I go through and do a few ways to solve it if it's possible to do it by 1 or 2. They are up there.
So it's like all those special prayers?
Yep. Okay. Yeah. Yes, it's kind of nice having more of it done than less.
Yeah.
And that's why I do that, and I have the review sheet, and y'all can use it because it's a good reference point to look back on. And realistically, especially once you get out into the real world, we do have resources. It's better if you can actually find something and reference it and apply it than just straight memorization at this point. Here, we need to get it equal to 0. Negative 3x squared minus 24x minus 48. If we want to find the value of the discriminant, we need the values of a, b, c. A is negative 3, b is negative 24, c is negative 48. Do make sure to put parentheses, especially around the negative 24. It will change the answer if you don't have them. And the correct answer is 0. Now, because it is equal to 0, we have one real solution. And that's it. That's all this is looking for. Questions on this here? Now, say, because again, we're going to need to, and I'm going to try to put a bigger focus on, especially relating some of these problems back to the ACT, since most of y'all are going to have to take it. On the ACT, it asks you to solve the following equation for values of x that make the function true. Well, if a value of x is a solution, makes it true, for this here, it's got to make 24x equal 48 minus 3x squared. The nice thing about a multiple choice test is it gives you answers. One of those four has to be the right answer, yes? So I can take those values, plug it in for x. If it makes both sides equal, both sides need to be the same value, that's the correct answer. If it doesn't, it's not. And that's the nice thing about a multiple choice test is we can just plug in those values, see what's going to make both sides be the same. As soon as we get it, we move on. So if we guess C and we plug in the value for C, and it makes both sides equal, the correct answer is C. Move on to the next one. If it's not, mark it out. Try another one. If C didn't work, you try B, B doesn't work. You try D, D doesn't work. Do we even have to try A? We had 4 answers. We took 3 away. That's it. It has to be A, so we move on. Not that I know of, unless you haven't taken the U.S. citizen, unless you haven't passed the U.S. citizenship test. If you passed it, have already taken the U.S. history test, which normally we just make all the junior state, and the ACT are the 3 main ones. At least standardized tests, anyways. Questions on this here? 31 through 33, create a perfect square trinomial by finding the value of C. And C is equal to B over 2 squared. Now, most of these here, x squared, there's not going to be a number in front of x squared, because completing the square, the first step is A equal to 1. If not, make it so. If A is already 1, we don't have to do anything for that. But let's look at 31. What's the value of B for 31? So negative 24 over 2 squared. They have a button cell battery in it. So, yeah, just put it on my desk. I'll replace it. Can 24 divide by 2 nicely? Well, yes, it's negative 12. Negative 12, we can now square it, telling us it is 144. So part of these questions, you do need to find the value of C. 144. If you want to rewrite it as x squared minus 24x plus 144, you can. You don't have to, but you can. Then at this point here, we also need to factor it. So it's going to factor to a single set of parentheses with x. Now the number and sign that goes inside these parentheses when we factor is the number and sign inside the parentheses before we squared it to find the value of c. And that number is negative 12, telling us this factors 2x minus 12 squared. So we need the x minus 12 squared, and we need the 144. We need both. Questions on this here? Now, as I said during the lesson, and as we went over this the first time, yes, I could put parentheses negative 24 over 2, close parentheses, squared, type the whole thing, and it'll tell me it's 144. The reason I do the division of 2 first is it tells us, okay, what's going to go inside that parenthesis before we squared is negative 12. It gives me that. Now, if we look at 29, or 20, let's try a third time, 32, what's the value of b for 32? Positive 29, yes? Does 29 divide by 2? Nicely. No. Since it doesn't divide by 2 nicely, we can't reduce it, we can't simplify it from there, so we'll leave it alone. And at this point here, we can put 29 over 2 squared, which is 841 over 4. Now, if you're not sure if it's going to reduce, like if we had 29 halves as b, which would be 29 over 2 all over 2, throw it in the calculator. Let it see if it will simplify, and it does, it will tell us. If it won't, it'll throw it right back. Because we could say 29 over 2 tells us it's 29 over 2. Now, if we had, say, 29 over 2, like I just said, it'll tell us, oh yeah, this will simplify to 29 fourths. So it'll simplify it for us if it will simplify. So if you're not sure, let the calculator do it. Now the number inside the parentheses before we squared it was 29 halves, not 29 fourths. So the factored form would be x plus 29 halves squared. Questions on this here? We good with finding the value c and factoring. Okay. We ready for the next piece? Yep. You ready for this part, the hardest part of the test? I to the nth. Whenever we have powers of I, we take that power and divide by 4. We're going to get one of 4 things. If the decimal is 0.25, it reduces to I. If it's 0.5, 0.50, it's negative 1. 0.75 is negative I. And 0.00 is going to be 1. Most likely, if it does give us 0.00 as a decimal, it won't give us any decimal at all. 0.00 just says it divides evenly. So the first one's I to the 27th. 27 divided by 4 is 6.75, which would be negative I. 287. Yes. 41. I, because it's 0.25. 2,874. Negative 1. And then this is, I think, negative I. Yep, because all we got to do is take that exponent, divide by 4, look at the decimal. Is it 0.25, 0.50, 0.75, or 00? Or essentially, is there no decimal? Now, the graphing calculator will do these. We just got to be careful because once we get over a certain power, it starts throwing in that pixel error, that negative 2e to the negative 2e negative 12. At that point, we might as well just divide it by 4 instead of having to plug it in and then interpret what it's saying. Yes? A, B, C, D. Which one do y'all want to look at? B. And we went through this process because there's not a sign in front of either one. There's not a number or sign in front of the first set of parentheses. We would drop them. because the sign in front of the second is a plus, we can just drop it. We distribute the positive 1. Combine like terms is how we did this at the start. Yes? First time we covered it. After that point, we said I can go 7i minus 27 plus 3i minus 2. It would help if I got I instead of a decimal. Second decimal will give us I. And it tells us that this is negative 29 plus 10i. If we looked at C, 6 minus 4i minus negative 3i plus 2, it'll tell us it's 4 minus I. We do have to be careful because between the two parentheses, we do need it to be minus. In front of this 3i, we need it minus, not negative. Because if it is, we do accidentally put a negative instead of a minus, it's going to throw up an error. Because what the calculator is looking for with that negative 3i, or essentially we put it as minus 3i, is looking for a number in front of it. It's looking for something in front of it that's not a parentheses. If you do get an error, the bottom one, go to, if you select it, it's going to put that cursor right there. It's saying there is something wrong with this here. Okay, yep, I put a minus instead of a negative. Switch it, got it fixed. Into the graphing calculator, not the yellow one, the 84, or the plug these into the 84 plus. Because even E, 189 I minus 361 I squared plus 71 I squared minus 38 I to the fourth. For our exponents, the button above the division key, that caret key, will let us do exponents. So we just put it to the fourth power. And really, 189i is fine as it is. The I squared, the negative 361i squared, well, I squared is negative 1. So the negative and negative make it plus 361. 71i squared is going to make it negative 71 because I squared is negative 1. And the negative 38 I to the fourth is 1, so just negative 38. It did all of that for us because if we were doing it by hand, we would have to simplify those and then add and subtract like terms. Here it just said, cool, it's 252 plus 189i. Questions on addition or subtraction? Multiplication, FGHI. FGH or I, which one do y'all want to look at? Because if we were doing H by hand, if we were actually working this out, the first thing we would do is multiply these two out. You don't have to write this, because it'd be 14 minus 8i plus 21i minus 12i squared. Combine like terms, well, I squared is going to be negative 1, making that plus 12. 14 plus 12 would be 26, plus 13i. Then we'd have to multiply by 6 minus 2i. 6 times 26 is going to be 6 carry the 3, 12, 156, minus 52i, plus 78i, minus 36i squared. Well, I squared is going to be negative 1, telling us that we have 8, 5, 6, and 8, 192 plus 26i. Nope, that's not right. That should be, I think, 182. Yep, because I got it off here. 6 and 6, 6. 2. Negative 26. Because 13 times 2 is 26, not 36. Giving us this here. Now, we can come over here and say 2 plus 3i, 7 minus 4i, 6 minus 2i. We get this here. We know how to do it. We know the process to do it. Now we're going to let the calculator do it. We're going to let our tools that we have do it for us. Questions on multiplication? Because even with k, 8 plus 4i squared times 16 minus 3i to the fifth, calculator will do that just fine. Yeah, because you can do it by hand. Yeah. All right, guys. So I will also say where I was marking that I squared out, because I treated it as -1. So it should be negative 12i squared. The negative I squared becomes -1, switching it from -12 to +12. If it had been plus 12i squared, we would cross the I squared out, cross the plus out, and turn it into a minus. If it's just I squared, it's going to become -1 or +1 if it's minus I squared. Yes. Now, L and M, we can type these into the calculator, but if we do, we have to change it to the numerator divided by the denominator. The top of the fraction divided by the bottom of the fraction. And we type this in. After we get our answer from typing this in, we're going to go math, enter, enter. So on the graphing calculator, we're going to put parentheses around the top, 8 minus 4i divided by 3 minus I, enter. So it's going to give us 2.8 minus 0.4. So we type, numerator divided by the denominator. When we hit math, enter, enter, so math brings up that list, and the first one in that list is fraction. So we hit enter to select it, and we hit enter again to tell it, yes, take the previous answer and turn it into fractional form. 14 fifths minus 2 fifths I. Is our answer. Now, the answer key for the review gives us this here, 14 minus 2i all over 5. They are the same answer. It's just the calculator broke it up into 2 fractions instead of 1. Now, up to this point, in most of the year, most every single test that I have, I do not care if you give it to me in decimal or fractional form. These here, I want them to be in fractions. I do not want them in decimals. For one main reason and one main reason only. Especially if you're typing in the calculator, it's 3 buttons, math, enter, enter, and it'll give it to you back as a decimal, or back as a fraction. Does this make sense? Do you want to see it worked out? Okay. Now, if we were to work this out by hand, we're going to multiply the top and bottom of the fraction by the complex conjugate of the denominator. And that's really what the calculator's doing. On bottom, we're going to multiply 3 minus I by 3 plus I. 3 times 3 is going to give us 9. 3 times I is plus 3i. Negative I times 3 is negative 3i. And I times negative I is negative I squared. We do the same thing on top. 8 times 3 is 24. 8 times I is plus 8i. Negative 4 times 3 is negative 12i. And negative 4 times positive I is going to be negative 4i squared. On bottom, probably don't need that big of a fraction bar. 3i, negative 3i will cancel. And really, I squared is negative 1, so negative I squared is just going to become plus 1. So on bottom, we have 9 plus 1, which is 10. On top, well, negative 4i squared is the same as just plus 4. 24 plus 4 is 28. 8i minus 12i is negative 4i. Yes? Now, if we want to, we can break this up like the other one did, like the calculator did. And it tells us that it's 28 over 10 minus 4 over 10i. 28 over 10 would be 14 fifths. It's going to reduce 4 over 10 would reduce to 2 fifths, telling us we have 14 fifths minus 2 fifths i, which is the exact same answer we got, yes? So we can do it by hand, we can do it in the calculator. Either one works. Questions on this here? Do we need another example of division? You want to finish writing that down? I didn't know if you were writing it down or not. I don't mind waiting if you need. Okay. You're welcome. Last part. Find the complex conjugate and their product. So complex conjugate, if we're given a plus bi, it's a minus bi. If we're given a minus bi, it's a plus bi. So if we look at the first one, 4 minus 3i, what would its complex conjugate be? 4 plus 3i. And there's half your answer. The other half, we have to multiply them together. So we have to do 4 minus 3i times 4 plus 3i. Now again, it's multiplication. We can throw it straight into the calculator and it'll tell us that it is 25. If we do it by hand, 4 times 4 is 16. 4 times 3i is plus 12i. Negative 3i times 4 is negative 12i. And negative 3i times 3i is negative 9i squared. 12i and negative 12i cancel. Our negative 9i squared, I squared is negative 1. So it's going to turn it to positive 9. And 16 plus 9 is 25. I know I'm skipping steps in that there because we would normally rewrite it with I squared is negative 1. Do our negative 9 times negative 1 to give us positive 9. And then combine. $18 plus 14i. Its complex conjugate would be 18. $5.20. And that's it. Because we're just switching the sign in front of the term with I, which, yeah.
When I plugged it in, it was an error, and I went go to, and it was the
Which, this one?
No, I did, and then it's still, see, go back up again. And then.
Oh, I see. So next to the negative 3i, there's no parenthesis.
Well, look, see on this one? That's my first thing. But when I went to go to, it took, like, I deleted it, and then it gave me that. But and it kept saying error. And I literally typed it in there.
Hit enter. Syntax go to.
What the heck?
Oh, the first parenthesis. You put a brace.
Oh my goodness.
That's the. You're not the first one to do that today. That's actually the second time that's happened.
I was like, wow.
Yeah, so that, it was wanting you to put another brace. It wanted it to match. So really, yeah. If it's, let's look at S. What would, this here, the complex conjugate would be negative 8i. 8i times negative 8i would be positive 64. We feel comfortable with this here, yes? Let's do one more. Let's do, I'm going to add U. What would the complex conjugate of 8 be? I don't think it's going to show up on the test, but if it does, we'll be ready for it. It would not be negative 8. Because we're changing the sign in front of the term with I. Now, 8 does not have a I with it. So really, we could consider it the same as 8 plus 0i, which complex conjugate would be 8 minus 0i. And if we multiplied it together, we're just multiplying 8 times 8, which is 60. Yeah. But that is the entire review sheet.